All right, number 16, we want to use the function to answer this part A through F. Okay, so we got several parts here. First part wants us to find the domain. So we have f of x is equal to log of x plus 4, and then plus 4 outside of parentheses. All right. So when we're dealing with domain, we're only dealing with the part that we're taking the log of. And so we want to figure out what would make this greater than 0. So x plus 4, I don't know why I'm writing that parenthesis there, greater than 0. In solving that, we will get x has to be greater than -4. All right, so interval notation, -4 to infinity would give us something greater than 0. All right, so for our domain, say -4 to infinity. All right, now we want to choose the correct graph. So again, log goes up and curves right. This plus 4 will shift the graph up 4 units. This plus 4 inside will shift it left. So my graph should be above and to the left. So that would match up with C. Would be the best image, just based on transformations. We also want to determine the range. So the range is always negative infinity to positive, and the shifting up and down, left and right doesn't change the range. Okay, let me go back and just show you right here. The range is negative infinity to positive, and shifting it up or down doesn't change that. So our range is still negative infinity to positive infinity. The vertical asymptote. Okay, so this is a new concept because our graph cannot cross the line x equals 0. So normally your graph goes up this way and curves, and it's right up against here. So this is like an asymptote. The graph will not cross. It's an imaginary line that the graph can't cross. When we shift our graph, when we move it left 4, it also moves that asymptote. So 1, 2, 3, 4. So -4 is going to be our new asymptote. So if your graph gets translated, moved, shifted, it also moves that asymptote. So that's kind of what you see in the graph that we chose when it got translated over here, graph C. If you count those tick marks, hard to see. -1, -2, -3, -4. No part of your graph is past -4. It's just kind of really close to that. So that is the idea there. So the vertical asymptote is x equals -4. Again, comes from whatever you get here. So that -4, same thing, similar to when we found the vertex and we did quadratic functions and we had to find the vertex of a parabola. The inverse, so we just want to take this function, and the inverse is going to be a little bit different though, because we have this plus 4 part. So let me actually work it all the way out when we do inverse. So the best way to do inverse generally is if I have y equals, I'm going to say log, what was that, of x plus 4, and then we got another plus 4. We're going to flip-flop x and y. That's how you find the inverse. You change x and y. They change positions. And then we would solve for y. Now, if I were to take a guess, I want to see if this works. So when we transcribe this, normally we would take this base, raise it to this power, and then I want to say if we subtract 4, move this 4 over as well. So we would have 10 to the power of y minus 4 equals x plus 4. And I'm not really sure how, if you could just subtract that 4 because that was in a different aspect of the equation. That raised to that power equals that. So it's different. I'm not sure how it works with that, but if I were to, I would probably put an 8 right there. But let's see. I'm going to just change x and y. So I'm starting here. I'm going to put an x here equals log of base 10. We're going to say y plus 4, and then the plus 4 on the outside. All right, so first thing I would do, so yeah, doing it this way, I would subtract 4 first. Okay, so I would first do subtract 4. So I had x minus 4 first equals log base 10 of y plus 4. And then from here, now that you have everything on 1, you take this and raise it to this power, and then we have 10, which I'm off screen now. We have 10 raised to the x minus 4 power equals y plus 4. All right, and then we would subtract 4. So yeah, that was very different. So then we would have 10 raised to the x minus 4 power, and then you move this 4 over, so minus 4 equals y. So this would be your inverse. All right, I probably could have got there. I just wasn't sure at first about moving that. So you would move that first, get the log isolated, and then you convert it to exponential form. So that's what we've done here. So I skipped some steps when I'm explaining what's happening. So you interchange x and y, and then you start solving for y. So you move everything away from y. So you subtract that 4, and then once you have the log by itself and no other terms, you can write it in exponential form. So just move that base over, raise to that power, and then the log is gone, and then you move that 4 over. So this is the inverse that we're looking for. So f inverse of x is the 10. I'm going to raise to the x minus 4 power, and then minus 4. Okay, so this is inverse. All right, the domain and range. Okay, so in the text we saw it once, but the domain and range of the inverse are just the opposite of what they were when you did the original function. So when we did the original function, our domain was 4 to infinity, or negative 4 to infinity, and the range was negative infinity to infinity. It was all real numbers. So when you change x and y, remember domain is associated with x, range is associated with y. So also do your domain and range change. So of this function, the domain is now what the range was. So the domain is now negative infinity to positive infinity, and the range is now what the domain was, which is negative 4 to infinity. So when you flip-flop x and y, you also flip-flop your domain and range. So this is what we want here. So the domain is now negative infinity to positive infinity. And the range is negative 4 to infinity. Okay, I forgot my negative 4 here. Sorry, negative 4 to infinity. Okay, and then we want to choose the graph. Okay, so it would be like the mirror image. It's like flipping it across the X. So it'll be coming down and then flipping it across the Y. So it'll be over here doing a mirror image over there. Again, you can graph it. That'd probably be the best way to visualize it. I can visualize a little bit better. So I'm looking at this shape right here. It should be on the left side of that graph. Okay, they don't like that. So again, it is hard to visualize that. So I was pretty sure it would be that one. I don't think it got moved over. All right, let me graph it. Kind of hard to graph these. Not really easy to do by hand, but let's graph it. Y equal, let's turn this on. Y equal, clear this out. We'll say 10. I'm going to raise it to, any parentheses here, raise it to the x minus 4 power, and then close, and then do minus 4. And then their window is going from -9, it could go negative to +9. So let me just go zoom 6 to get the standard viewing window. Okay, so it comes all the way over and goes up, so on the right side. So not this guy, not this guy. It's below the line, so A is the one that matched. So probably be best just to graph it. Trying to visualize it, it's really hard to do that.